Halo, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azlan Hakim bin Zaharuddin.
My name is Imran Najmi bin Badri.
My name is Muhammad Hazib bin Nazri. So, what is integration? Integration is a way of adding slice to find the whole. Integration can be used to find areas, volumes, central points, and many useful things. So, I have an example. As you can see, we want to find area of the shape. So, we can just cut into triangle and rectangle shape and use area formula both shape, and then we got the area, right? But what if shape that have curve like this? So that's why integration comes in. So here I have a function. I want to find the area under the curve of a function. We could calculate the function at few points and add slice of with delta x like this, but the answer will not be accurate. We can make delta x a lot smaller and add up many small slices, then answer is getting better. And as the slice approach 0 in width, the answer approaches the true answer. Now we write the x to mean the delta x slices are approaching 0 in width. So there is a three method how to calculate the value. So first one is this, second washer and shell. So how to determine which method to use for volume? First is the strip perpendicular or parallel. If parallel, use shell method. If perpendicular, does the strip sit on the rotating axis? If yes, use this method. If no, use washer method. Method and equation. This. So the formula is pi r this power of 2 dx or dy. For washer, pi r big this power of 2 minus pi r small this power of 2 dx or dy. For shell, 2 pi r shell times h shell dx or dy.
So, while I drinking, I wonder how many this cup can hold. And I decide to finish my drinks. After finishing my drinks, I start to take a measurement. Then after that, I use volume by cylindrical shell method that I've learned before. Here are the 3D model of the cup. And here I have the complete calculation. I will now have to let my friend Imran to show us what and how this calculation works.
So let's look at our graph. As you can see that I have already drawn the graph based on the information that our friend Asno gave us. And this will be the shell formula that we will use to solve this problem. So we move the 2 pi to the front because it is a constant. So now how do we find the shell radius? Well, if the strip is horizontal and above the rotation line, then it's y minus the rotation line. But if the strip is below the rotation line, then it's the rotation line minus y. Same goes with the strip is vertical and on the left side, then we take the rotation line minus x. Then if the strip is vertical and on the right side of the rotation line, then it's x minus the rotation line. If you want to find the shell height, on the other hand, it depends on the strip. If the strip is horizontal, then we will have to minus x right by the x left. Then if the strip is vertical, however, we have to subtract the y top by the y bottom. So now, after we apply all that, we will get this new formula. So for the shell radius, our strip is on the right side of our rotation line. So we use x minus the rotation line, in which is 0, because our rotation line earlier is exactly on the y-axis. And we know that the y-axis is x equals to 0. And for the shell height, since our strip is vertical, we will take the y top, which is 7.5, minus the y bottom, which is x squared, which is the function of the line. So knowing that our boundaries are between 0 and 3.5. So now we will solve this by multiplying x into the brackets. So now we will get 7.5x minus x to the power of 3. Next, we integrate those numbers and we will get 7.5x to the power of 2 over 2 minus x to the power of 4 over 4. So now we will solve this using definite integrals where the upper is 3.5 and the lower is 0. So we substitute the 3.5 and 0 to the function and we will get 7.5 times 3.5 squared over 2 minus 3.5 to the power of 4 over 4 minus 7.5 times 0 squared over 2 minus 0 to the power of 4 over 4. So now after we press our calculators, we will get 45.9375 minus 37.515625 minus 0. And then we times this by 2 pi that we put at the front earlier, and we will get our final answer, which is 52.916 unit cube. At the end of the day, Shell's method is one of the three ways that we could use to calculate the volumes of solids of revolution, which are the application of calculus. As we all know, the solids of revolution are used in the manufacturing of items such as pistons, bottles, axles, pills, and funnels, and these are just one of many examples. The Shell's method is one of the three ways in calculus that we could use to calculate the volumes of the unique shapes of different solids of revolution. Thank you all for watching, and thank you Miss Fatiha for the tremendous support, and inshallah I will see you all soon. Assalamu alaikum.